All right, if you're serious about taking your PLC programming from just good to truly great, then you absolutely need to master one of the most powerful tools we have, the user-defined data type, or UDT. And trust me, this isn't just about making your code look neat. It's about building logic that is smarter, faster, and way more efficient. So let's dive right in.
First things first, take a look at this. Which one of these would you rather deal with at 3 in the morning during a shutdown? On the left, you've got what I call tag bloat. It's a chaotic, endless scroll of individual tags for just one motor. And on the right, you have one single, clean, perfectly organized tag. It's a no-brainer, right? That clean approach is exactly what UDTs give us.
So here's the roadmap for today. We're going to start with the problem, that tag bloat. Then we'll introduce the solution, the UDT blueprint. We'll actually build a real-world example together. After that, we'll get into some advanced stuff like nesting, I'll share a pro tip on memory, and then we'll see why all of this becomes so critical when you start working with arrays.
We've all been there, right? The program starts small, but it grows, and suddenly you're scrolling through this massive, unstructured list of tags. It's an absolute nightmare to manage, a real headache to debug, and it makes scaling your project almost impossible. Just trying to find one tag like motor101_fault_prod in a sea of thousands is a massive waste of your time.
And this is where the user-defined data type swoops in to save the day. The best way to think about it is like a custom blueprint for your data. So instead of creating a dozen individual tags every time you add a motor, you create one perfect motor blueprint, and then you just reuse it again and again. So what is it exactly? Well, a UDT is a custom data structure that you create. It lets you group all the related bits and pieces of data for a real-world device, a motor, a valve, a sensor, into one clean logical package. You're no longer stuck with just the basic bools and dints. You get to create your own perfect data types that match what you're actually controlling.
And the benefits here are huge. You define your blueprint once, and you can use it for hundreds, even thousands of devices. Your tag database instantly becomes cleaner and way more organized. But here's the real magic. Let's say you need to add a new feature, like a fault reset button. You just update that one UDT blueprint, and boom, every single motor in your entire program gets that update automatically. For maintenance, that's an absolute game changer.
Okay, theory is great, but let's get our hands dirty and make this practical. We are going to build a UDT for one of the most common devices you'll find in any plant, a variable frequency drive, or a VFD.
See? This is how a UDT brings beautiful order to all that chaos. All of our VFD data is right here, in one place. We've got our commands like start and stop as bools, our analog values like speed and current as reals, and our error data as a dint. Everything you could possibly need to control and monitor that VFD is now bundled into one single logical structure. And creating this in your programming software? It's ridiculously straightforward. You just open the UDT editor, give your blueprint a name like VFD_control, start adding the members and picking their data types, and then you save it. From that moment on, you can create a new tag and simply select VFD_control from the data type dropdown. It's really that simple.
Okay, you ready to level up? We can actually take our organization a step further by nesting UDTs inside of other UDTs. Think of it like those Russian nesting dolls, but for your data. It's pretty cool.
So let's start by creating a smaller, super specialized child UDT. We'll call this one maintenance info. Its only job in life is to hold maintenance-related data. How many hours the motor has run, how many times it's been started, and the date it was last serviced. Okay, now for the really cool part. We go back to our main VFD control UDT and we add a new member to it. But here's the trick. Its data type isn't going to be a bool or a real. We're going to set its data type to maintenance info, the very blueprint we just created. Now, before you go nesting everything, there are a few important rules you gotta remember. The controller is still pads memory, which we're about to talk about in a second. You can't nest a UDT inside itself. That would just create an infinite loop and break things. And, this is a big one, you have to be offline to change a UDT structure, so you need to plan ahead. And that brings us to the pro-level tip that really separates the experts from the amateurs, memory optimization. Because it's not just about what data you store, it's about how you store it. So let me ask you a question. You've perfectly grouped all your data inside your UDT, but does the order in which you list those members actually make a difference? The answer is a resounding yes, and it can have a huge impact on your controller's memory. Okay, so here's the deal. The controller doesn't think byte by byte. It thinks in these 4-byte chunks, or words. In scenario A, we've sandwiched a 4-byte reel right between two 1-byte bools. To keep everything lined up neatly in its memory slots, the controller has to add 3 bytes of wasted padding after each bool. The result? It's using 12 bytes of memory to store only 6 bytes of actual data. But look at scenario B. By simply grouping the bools together, they get packed neatly into a single 4-byte word. There's no wasted space, it's the exact same data, but now it only takes up 8 bytes.
And when you see it visually like this, the impact is obvious. We're talking about a 33% memory saving just by reordering a couple of lines in your UDT definition. It's just like packing a suitcase. If you do it carefully instead of just throwing everything in, you can fit a whole lot more.
So how do you do it right every time? Just follow these golden rules. A great rule of thumb is to order your members from the largest data type down to the smallest. Always group your bools together. The controller can pack 32 of them into a single 4-byte word. And try to pair up smaller types, like 2 ints or 4 SINTs, to perfectly fill a word without any waste. Now, you might be sitting there thinking, come on, we're talking about saving 4 bytes. Who cares? Well, you start to care a lot when you start using arrays. This is where those small, disciplined savings turn into massive performance gains. Let's put some real numbers to this. If you create an array of, say, 1,000 of our unoptimized UDTs, that 4 bytes of waste per instance suddenly becomes 4 kilobytes of totally wasted controller memory. In large applications, that's a huge deal. And this isn't just about saving memory. Smaller UDTs mean smaller data packets, which leads to faster communication with your HMIs. It also unlocks some incredibly powerful and efficient logic using things like indirect addressing. And here's one last pro tip for you. If you optimize everything, and you still have some leftover space in a 4-byte word, throw in some spare bools. The memory is already allocated anyway, so those tags are essentially free. So you've done it. You have mastered the art of organizing your data. Your tags are tidy, your structures are perfectly logical, and your memory usage is incredibly efficient. But that just leads to the next big question. Now that your data is perfect, how do you make your logic just as reusable and powerful? And that is a story for another time. Thanks for joining me.